Hello, Fuzzy. Welcome. Today I'm doing just great. Thank you for asking. I hope you're doing well yourself. It's been a whole week since we've seen each other, I think. Is that right? No, maybe not. I've lost track of time at this point. I'm in the void. Let's see where we are today. Okay. That's fair. That's totally fair. Hello, Brandon. Welcome. Let me try that. I saw a post the other day that said, like, I'll guess your age based off of your favorite Pokemon game. And it was pretty spot on. I myself grew up during the era of Ruby and Sapphire and Emerald. Those were my games. You guys are a little bit younger than I am, so I think it would make sense. So the new Pokemon, isn't it Pearl or something? The one with, I'll probably say it wrong. Giratina? That kind of centipede looking thing. I could be totally wrong. I may be offending you right now, and if I am, I'm sorry. I'm a little off. I guess Platinum was before Diamond and Pearl. Oh, okay. Let's see. Make that a little bigger. Good morning, Hamma. Thank you. Thank you. I appreciate that. Good morning, Synthos. Good evening. Good evening. All right. It's almost 11:30 here. Good morning, YCS. Now, let's see. I've made a mistake, as I always do. So, I said I was going to do a video for this, and I didn't. As I'm sure you guys are in similar situations, I myself have quite a few projects that are due right now, and I kind of got sucked in there. So, yeah, there is no video for this yet. So I'll briefly introduce it. I know plenty of you have gotten started already. And I'll do my best to make a video sometime today. All right, but let's just briefly talk about the assignment. Now, I'm also going to say, I know the new Pokemon game is out, but if there's any day that you want to pay attention, I think today would be a great day to do that. And why is that? Well, let's go ahead and look here. Today, we're going to spend most of our time coding our linked list class here. Okay. And guess what? There's going to be a bunch of stuff in here that's going to help you out with the assignment. So please, You know, if you're too busy playing Animal Crossing or Pokemon or something, maybe, you know, just watch here for the next hour and a half or however much time we have, hour and 15. And you're going to get a lot of good hints for the assignment. You're going to get a lot of good code. So please do pay attention to that. Now, we are just going to talk briefly about the assignment so that you guys know what's going on. There's quite a few things kind of happening here. And so that's kind of why I need to make a video. But the first thing I'll say is I did make this assignment. And if you have some friends that are in future or like they're ahead of you, you'll know that this assignment has been done before. Now, do not use that as an excuse to go get help from your colleague. All right, I have every single assignment that's ever been done for this one. I will be mossing them, and if I find that someone had copied code from a previous semester, I will not only reduce your grade, but I will go out of my way to reduce that person's grade. I have the ability to do that. So, please work on this yourself. It's a hard one, all right? It's a hard one. So, you know, chances are, even if you do ask your old friends for help, they'll be like, no, I have PTSD. I'm not going to help you with that. All right, so just so we're clear on that. Now, that being said, let's go ahead and kind of talk about what's going on here. This is just a little card simulation game. All right, War. I don't know if you have ever played War before, but it's very easy. I do offer some instructions for this game if you ever want to play it. But basically, two players sit across from each other on each side of the table, and they each have half of the deck, and they deal out a card. They flip it over, and the person who has the higher card wins, and then they take both the cards and they keep going. Now, there's a few kind of different things that happen. Now, if you want to read this, you're welcome to. Lucky for you, I did the game part. All right, so the game will work automatically because the link list stuff is already pretty complicated. So, just that being said, yeah, you really don't have to read this if you don't want to, but if you want to know what's going on, you'll see that. There are 6 files. Really, the only one you have to worry about is card.cpp. All right. And you have to code the card class. All right, this one's pretty easy, or it's simpler than the deck class, because then you have to code the deck class, and that is the linked list class. Okay, that's the linked list class. Now, just a few notes. Each card has a few different things going on. If you go take a look here, you'll notice that they have a suit and a value. This is pretty standard for any card. This is when you're saying this is the ace of diamonds, or the ace of diamonds. We put the suit first and then the value second, or a 2 of diamonds, or a let's see what we do here. Maybe a 10 of spades. That's how we're representing this. So the suit is either spade, club, heart, or diamond. And then the value is 9 through 2, 10, jack, queen, king, ace. Now there's a weight here, all right? This is a weight. This is just an integer. For those that you don't know, that's just an integer. A short is using, I think, 2 bytes. 2 bytes instead of 4 bytes on a regular integer. All right? Now this weight indicates that, say, the jack is greater than the 10, the queen is greater than the jack, the king is greater than the queen, and the ace is greater than the king. So you need that weight to be able to tell who won. When 2 people deal out some cards, you're going to say, who won this one? Well, you have to look at the weight. And my king has a higher weight than your jack. So that's what that's for. So you've got some constructors. You have to initialize that stuff. Here's a string that will convert this into, or here's a function that will convert it into a string. You'll have to look at the format, but I think it looks something like this. That might be the ace of diamonds card. Just returns a string that looks like that. Pretty simple. And then here we have some operators. Now, these operators are specifically for sorting, all right? There's some confusion on that. Has nothing to do with like which card wins. With which card wins. Now, I don't want to say it has nothing to do with weight because it kind of does. But it's purely for sorting. So instead of saying that, I'm just going to say purely for sorting. And so that is the suits will be in alphabetical order. All right. And then let's say you're comparing two cards that have the same weight. For example, you have four diamonds, and then say you have the king of diamonds. I want you to sort these two elements. Now, alphabetically, the suits are the same. All right, so the diamond is not less than. Now, instead of looking at the value, I would rather you look at the weight here. All right, I want you to look at the weight. All right, so if you're going to be sorting this, it's always going to start DA, DK, D Queen, Dairy Queen, D Jack, D10, D9, so on and so forth. So this less than operator and greater than operator, they're going to check the suit first. It will sort the suit alphabetically, and then once it does that, it will then sort off the weight, such that when the deck is sorted, it's got this nice format. All right, it's got this nice format. I'll show you that. Yeah, it's 10. Unfortunately, I can't represent 10 with a single character, so it's T. And then lastly, the get weight, all right? And that just returns the actual weight of the card. So that's one card. Now you have the deck class. Now if you look in here, you'll notice you've got your, what is this? What is this? What is that? That's a singly linked list, isn't it? That's a node for a singly linked list. So there's your node. Now guess what? It is inside of the deck class. It's inside. So what does that mean? Well, every time you want to declare something, for example, let's see here. Look at this operator here. Look at this operator here. If you want to declare this outside of the class, which I think you have to, and I may have given you the skeleton code already, you have to do two things. For one, you have to say, well, this operator belongs to my deck class, right? But you're not done. You have to also suggest that this node belongs to your deck class too. Why? Because that node is declared inside of the class. So that type belongs only to the deck. And so if you ever want to kind of declare a return type of this, or if you want to declare a new node and say a global function, you have to use the scope resolution operator for it. Now, there's a whole bunch of stuff going on in here. I'm kind of going to stop here with that part. I'll leave it for the video later, because today we're really going to cover all of these. Today, this might happen in class. All right, this might happen here in class. We already did this last week, right? Wow, so that happened in class. This is going to be something like push front, wink, wink, winky face, right? If you're going to add a card to the top of the deck, it's like maybe putting an element at the front of the list. All right, so that's maybe doing that in class today, push front. Remove top card. Now, this might be similar to delete at, but I'll leave that one up to you. Shuffle deck. Now, we do have to talk about this part here, okay? This is kind of, this is where things get a little weird. Now, in previous semesters, I would have you guys come up with your own shuffling algorithm. I want you guys to have fun with it. But guess what? We've got code grade. So if you do it how you want to, then you're not going to match the output. And that's a problem. So if you notice, all right, if you noticed, I put in the announcements, I gave you some stuff. So you can go to Web Campus, and there's something there called provided functions. Provided functions. And so in your... if you download this, I know you guys can't see this really well, but there's two text files here. These are the shuffle functions. These are the shuffle functions. So before I go over those, let's just talk about why there's two and what the extra credit is. So there's a function here called swap cards. Swap cards. in which this is just like any other linked list. Now let's go ahead and pull up a paint diagram because this is very important. This will go in our notes today anyway as well, so it's good that we're going to go ahead and get started with that. We'll make that white, we'll make that black, and then we'll Control-Shift-I, and we are good to go. Now, hopefully you can see this. Let's go ahead and make ourselves some nodes, just some standard nodes as before, like this. And we'll go ahead and put a little line in there to indicate that this is a singly linked list and that there's going to be some data and there's going to be some next pointer, and that's it. And then we'll also give it a little arrow here. Okay. So here you have a little linked list node, SLL, right? And so your linked list might look like this. Let's go ahead and actually make a linked list here. So let's say our deck has 3 cards in it. In fact, I kind of want it to be more than that. I think at most we'll do that. Let's put 5 cards in it. Okay? So let's say our deck has 5 cards in it. All right? Now, it doesn't matter what's in here. But if you want to be picky about that, this could be the Ace of Diamonds. Right? This could be, I don't know, you shuffled the deck, right? Or this is kind of how we're going to shuffle the deck. We need some way to sort the card, or to shuffle the cards. So we need to move them around. Now, we don't have hands in our computer, right? So we can't, like, do the standard shuffling thing. So we're going to have to just swap a whole bunch of cards around, basically. So this function is very important. Let's do Spade King or something. Let's do Club 2. Let's do Club 3, and then let's do Heart, I don't know, 6. And then we're at the end of our list, right? So you all know that this is probably pointing to null pointer, okay? And then you also probably know that you have a head, all right? And the head pointer is what is looking at this memory location here. So I'll just indicate that there, all right? So, hopefully you guys agree. This is what our linked list looks like. Now, swapping cards. There's an easy way to do it, and there's a hard way to do it. Now, I'm going to kind of give you a little bit of a hint here. This is a test question. I believe this is also a PDF comprehension question. So, let's listen up. There are really only... Well, let me see here. Let's double check to make sure I'm not crazy. I'm not messing things up. All right, that's fine. Yep. So there's really only 2 ways to swap nodes here. Now, there's a super easy way to do it. Now, here's the easy way. And if you do the easy way, you're going to get 0 points for this function. You can swap the data within the nodes. You can swap the data within the nodes. So suggesting I'm going to say swap, I don't know. Let's make some arrows here. Let's make some arrows. Let's say I'm going to swap this one, and I'm going to swap this one. Now, the easy way, the cop-out way, is to say, I'm just going to pull this SK out. I'm going to pull this C3 out. I'm going to put it over here, and then I'm going to put that in there. Now, that's the easy cop-out way. Can anyone tell me why that might be a disadvantage? Of course, there are some cases where that's fine. I would say in this assignment, it's not really a big deal. But does anyone have any ideas on why that might be a disadvantage, or why we maybe wouldn't want to do that ever? So that's number 1, by the way. Let's make a note here. Well, so you're right in that there's no addresses that are changing. Yeah, so these are not templates. So in the case of this, we know that the types will be the same on the inside. So I wouldn't go as far to say that. But there's a little bit of a note here. So maybe before we continue on, let's just mention both of our methods. So swap cards method 1 is just swap data within the node. Okay, that's method 1. I'm going to put it down here. And then let's do another one. Now I'll make this, I don't know, yellow, something like that. Swap cards method methods. Method 2. Now this is actually not going to move the data within the node. In fact, it's just going to adjust the next pointers. It's just going to adjust the next pointers. All right. Ooh, that didn't go well at all. It's just going to adjust them. So what does that mean? Well, if we're going to be swapping, say, these two elements here, this one and this one, if we're going to be swapping them, we're not going to move the data. In fact, we're going to just say, hey, we're going to kind of, I'll draw some terrible lines, but then I'll illustrate it a little bit better. We're going to say, hey, head, you are now pointing to this one. And you're going to say C3, you are now pointing to this one. And you're going to say SK, you are now pointing to this one. So terrible, terrible little arrows I've drawn there. But hopefully you get the idea. And that we're going to say, hey, this node is just going to look elsewhere. This node is going to look elsewhere. And that node is also going to look elsewhere. Now my question is, when is this an advantage? Why would this be advantageous over this method? So Chef asks, do we say C2 is looking at... Oh, yeah. Yes, so here's where we're getting a little complicated. Yes, you're absolutely right, Chef. You're absolutely right. So let's make it a little bit simpler to begin. Let's make it a little bit simpler. Let's make it a little bit simpler. There we go. Let's start with that one, okay? Let's just start with those. All right, let's just start with those. Now, how many pointers do we have to update here? Well, this is kind of what we're gonna work on today. All right, this is kind of what we're gonna work on today. There's two cases with this method too. All right, there's two cases. Kind of put them in some notes here. I don't know what color I'll do. Different color this time. If we're gonna be swapping cards, just by updating the pointers, we have two cases. Case one is the cards are adjacent. What does adjacent? What does adjacency mean? Does anyone know? So case one, cards are adjacent. And then case two, cards are not adjacent. Let's see. They are right next to each other. Yes, so that's what adjacency means. So in this case, these cards are adjacent in that they are right next to each other. So I think I asked this question to Top Wolf, right? So you're right. We'll get the answer. In case one, how many pointers do we have to update? If we're swapping adjacent cards, how many pointers do we update? Case one, how many pointers do we update? Let's see if I can make that small. A little bit smaller. Ooh, not that small. 26. All right. None. Well, let's see if I can kind of clear this up a little bit. So if we're swapping these cards, let me draw these lines again, and then I'll actually kind of put it out here. But we need C2. Where is, if we're going to swap C2 and SK, where is C2 looking next? Case 1. Yeah, you're right, you're right, you're right. I'm being confusing. Method 2, case 1. You guys are absolutely right. You guys are absolutely right. I'm being confusing. Method 2, case 1. Yeah. Sorry about that. Sorry about that. My bad, my bad. Method 2, case 1. How many pointers do we update? 3 pointers, absolutely. Okay. So, do we follow this in that we're going to have to update this pointer here, C2. We're going to have to update this pointer here, SK. And we're going to have to update this pointer here, C3. 3 pointers, absolutely. Now, let's identify these. This is going to help you with the code, okay? Let's identify these. In case 1, what are we updating? Well, you're going to update a few things. You're going to update what I call the left node pointer, the left node next. Okay? You're going to update the right node next. And this one's a little bit complicated, but you're going to update the left previous node next. Those are your 3 updates. Yep. 3 pointer updates. Let's identify them. The left node, this is our left node. Do you see that it's on the left side here? This is our left node. So what do we have to update? We have to update left node next, which is this arrow here. We have to update left node next. The next one we have to update is the right node. This one is on the right side. And we have to update the right node next. So it's that one. Here it is. And then we have to update the node that's previous to the left node. It's this guy. Do you agree that this node here is previous to the left node and that we have to update this? And so when we update these nodes, you will see a few things happen. I'm going to kind of just move them up. I'm going to extract them. I'm going to lift them into the sky. And then let's say left node next is now pointing to H6. We're going to say that the right node next is now pointing to C2. But at the same time, we're also going to say that the left previous node next is also pointing to SK. So Chef says in an SLL, how do we get to that previous node? It's exactly right, and that's why this assignment is fun. So, here's method 2 and method 3. Now, I'm making you do this because you're going to have to keep track of this, all right? When you're traversing the node, you're going to have to find this. Now, lucky for you, I may go over this today in class. And if I do, I would strongly recommend you try the extra credit, because where does the extra credit come in? Well, here's where the extra credit comes in. Extra credit comes in when you're doing this. So let's go ahead and make an adjustment here. What do you say? Let's talk about method 2. And take a guess here. How many pointers do we have to update? And can you identify them? Method 2, case 2. How many pointer updates? How many, and can you identify them? Make this a little smaller. Four. Yeah, there are 4. Can you identify them? What are they? I can give you the easy ones, right? The easy ones are here. I just copy them, really. We're going to have to update these ones, right? But what are the other 2? Head next, next, next. Now, I would prefer kind of Top Wolf's here lingo, I guess is the word. Yeah. So Synthos, you're getting it, right? We need to know the left previous next. All right, the left previous next. And we need to know the right previous next. This is why there's an advantage. Yes, exactly, Chef, exactly. This is why there's an advantage to case 1. So what is the assignment? Well, assignment for full credit, you have to do case 1. If you want extra credit, do case 2. All right? So all you have to do for full credit is make a swap function that only swaps cards that are right next to each other, okay? This is for full credit. All right? This is for full credit. You can just do the assignment and start with that one, and it will do that. Now, in case 2, if you're going to swap, say, cards that are not adjacent, it gets a little more complicated. Not too bad, but it still gets a little more complicated. And that's where I'll offer you some extra credit. Now let's talk about how that works. Well, in your shuffle function, depending on how you shuffle, to match the code grade output, things have to look a little different. All right. So in the regular shuffle function, this is for full credit. Case 1, you're only swapping adjacent cards. You'll notice that the cards that we swap here are right next to each other. So we'll get a random card. This is at index 1. And then I2 is either going to be to the left or to the right of it. Left or right of that card. So I would recommend that you use this function here. In fact, to get full points, you'll have to put this shuffle function in your code. All right, because of the code grade. So you will have to use this function. All right. Now, guess what? If you write a function that can swap any two cards, you can just kind of skip over case 1 because in your, let's say you do the second method in that your swap card function swaps any two cards, it should be able to swap cards that are right next to each other. Basically, no matter what cards you throw at it, it will swap them. Are they right next to each other? Are they not? Are they the same node? Like all these cases, they'll be handled. All right. So if you just want to go for gold, you can just try the extra credit right away. Make a swap function that does that. And if you are successful, guess what? To get the regular credit, you can use this function. And then when you're ready to do the extra credit, just go get the extra credit, which is here. Plug it into your code and submit it to the other assignment. Notice here it doesn't matter what two cards I get. I just grab two random cards and I swap them. But in the previous example, they have to be right next to each other. So does that make sense? I have spent a little bit of time on this, but I will kind of slow it down, and I'll make a video if you need to come back to talk about this. But up until this point, do you have any questions on what the extra credit is, what's not, what needs to be done, and that how you just plug in these shuffle functions in order to match the output? Syntho says, I'm a little confused between the shuffle and the swap deck. Well, it's not swap deck, it's swap cards. Where is it? Swap cards. So this is the function that has extra credit associated with it. All right. Now you can do easy mode. This is what I call easy mode, where you just swap the adjacent cards. Swap adjacent cards. All right. And then there's hard mode, which is the extra credit portion, where you swap any two cards. All right, so this is for extra credit, and this is just for regular credit. Now, when you go, I'll just pull it up here. I think it'd be good to show. But we do have to get to the linked lists here. So we're going to do this one thing, and then we're jumping right into the linked lists. All right, we're jumping right into the linked lists. So you go to Web Campus, you're a student, so I'll pretend to be one. You just sign in here. Oh, you lost me, I bet. Or the connection got a little wonky there. We'll go here. I'll disguise myself as a student. I'll go to assignments. And what do we see here? Okay. What do we see here? So here you have assignment 9 extra credit. So when you submit assignment 9 in your code, you better use the shuffle deck regular. In order to match the output, you need to use this function. All right. No matter what method you do, whether you do hard mode or easy mode, to get full credit from the regular assignment on code grade, this code needs to be in there. Now, if you are attempting the extra credit, this is when you go back into your code and then you say, hey, swap function, please be different. And now you'll plug in the extra credit shuffle deck function. So then you'll come to extra credit. You'll do 2 different submissions, and for each of those, you're going to have a different shuffle function. Synthos asks, we can't do the swap data because yeah, so I'm warning you, Synthos, if you do the swap data, if you just swap the data as an easy cop-out, I will manually review your code and I will deduct you points for that. I won't drop you to 0, so for those of you who are cramming, I won't give you a 0 for the assignment because obviously everything else has to work. But if you do just swap the data, I will mark you for that. I'll come find you. So watch out. All right. So hopefully that's making sense. That's where we're going to cut it, okay? So I will upload a video. Come to office hours if you need. We'll talk about it some more. But just so you know, this is what's going on. And today in class, if we get to it, maybe we'll talk a little bit about this. Chef says, so we have the head node in the class, so I'm guessing we're going to have to use that to access the previous node in SL. Yep. It's just a regular singly linked list. You're always going to use the head node to get anywhere in the list. So let's get started today. So if you recall last class, we'll be using this paint diagram today. Let me just save it right now before I destroy it. All right, I've saved it. Now let me destroy it real quick. Let's just get rid of this stuff. Okay. I'll keep that there, but that will go away. That will go away, and that will go away. All right. So this is going to be our link list, and we're going to use that today. So if you recall from last time we got started on this, right? This is similar, right? This is like your deck class. Wow, deck class. Amazing. Okay. So here you've got your head, you've got your size, and then we did a recursive clear list function, which we talked about. Now, if you were confused on how this worked, I uploaded a short YouTube video for you. It's about 10 minutes. You can go watch that if you want. But we did code those. So we did a recursive clear list function, we did a regular iteration clear list function, and we did the destructor. What does the destructor do? Well, it just calls clear list. Why not? Okay. We also did a default constructor, so hopefully you're okay with that. Now, before we move on to anything else like this hard stuff here, I'm going to comment some of them out. We'll come back to the copy constructor. We'll come back to the operator, but let's just start with a few of these things. Let's do our push front. Let's do our get size. Let's do our operator. And I'm even going to add one more. Let's do an operator for an output. What do you say? So let's go ahead and make a template here. Type name, I guess type 1. And then what is this going to be? Well, we'll make a friend OStream. Operator output. What does it take? Well, it will take an OStream out, and it will go ahead and take a link list. What did I call it? An LL. It'll take an LL. I'll pass it by reference. I don't mind. Linked list. Okay. So we'll go ahead and start with some of these, just so we can make sure things are working before we hop into the even harder stuff, all right? So I'm going to pull that out here as well. Whoa! Don't need to see that. So let's get started with some easy ones. Let's do a push front. What do you say? Now, what does this one look like? Take notes, folks. What's going on here? Well, if I had to guess, in the assignment, this might be something like add to top of deck question mark. Okay, so now that we know that, what does this function do? Well, we're going to add an element to the top or the front of our linked list, to the front of our linked list. Okay. So we have an item here. Yes, it will be the head node. You're right. So look here. I'm going to make this even smaller. Things are getting smaller. Okay, so we're going to grab, say, I don't know, SK here. It doesn't matter what's in this. And we're going to say, hey, I have a new node here. And where do I want to put it? I want to put it up here. Did you guys lose me? That's just Cade. Maybe we're having a jumpy connection. We'll keep an eye on it. Oh, whack, I'm back. All right, so what are we going to do? We're going to take a new node here, and we're going to put it right here at the front of the list. So we're going to have to do a few things. Now, what's the first thing we have to do? What do you guys think? We have an item, we have some data, but what's the first thing you think we have to do? I mean, we can't just, fortunately, we can't just shove this into the list. We have to take a few steps. Yeah, that's exactly right. So step one, I'd say we got to allocate some memory. New node. So what do? Well, let's go ahead and say, I think I named it node type. It will be a pointer, your favorite. New node equals new node type. We've officially allocated some memory. So what does that do? Kind of here, that makes this pop up. Now it's floating. It's floating in space. We have it. Now we need to link it in there. So that's step one. What do you think step two is? We have a few options here, but I'll go with whatever you'd like. What do you think step two is? We could take a few steps. I'm happy to do any of them. But let's see where you guys take us. I'm interested to see. Put the item in the data. I'd say that's my favorite. Let's go ahead and do that, and then we'll go with Synthos there next. Put item into node. I like that. So we're going to go ahead and say, hey, new node, your data is equal to the item. Very good, very good. Step three, let's look at this. Point the head to the new memory. All right. Let's be careful here, though. Point head to new memory. So I say this. Head equals new node. Is there an issue here? Now, I see Chef is saying some stuff there. So we'll come back to this, but I kind of want to check in with Synthos and some other people. Is there an issue here? And what's the issue? What did we just do? What happened? We just lost the rest of the list. We just lost it. Here's what we did. We said, all right, head equals this. This is now floating in space. And it's gone. Do you understand that? So remember, with just a regular singly linked list, there's always some pointer pointing to it. That's how we get to it. All right? And so what do we have? We have this head node, and this head node is always pointing to the start of it. Here it is. And this is how we get to every element in the linked list. Now, in this code here, we made this bit, right? We made that, which happens to be this part here. And then the next thing we say is head equals to this new node. So no, we did not make an alias. We just assign the head to look here now. And now this linked list it's a memory leak. It's floating around in space. We'll never get it back. So what do we have to do before that? Well, Chef kind of said it there. We have to make a link. We have to make a link first. So how do we make that link? Well, very simply, we're going to link it. Step 3, link it. We're just going to say, hey, the new node next equals the head node. You agree with that? The new node next, whoops. Scary things there. The new node, this is our new node, right? New node next equals head node. There you go. So now it's linked. Now, just to keep in mind, we do have a pointer to this thing, right? We do have a pointer to it. It exists. We're currently storing it in new node. Okay? We're currently storing it there. So we can still get here. That's what I'm saying. That's all I'm saying. We can still get here, right? We've linked it into the list. And so finally, step 4, all we have to do is say, hey, we're going to go ahead and point the head to the new memory. And then maybe step 5, if you wanted to, size plus plus. Or we'll do the Mr. P special, plus equals 1. That's my favorite. And that's that. What do you guys think? Is that okay? Pretty simple. Step 1, allocate some memory. Step 2, put the item into the node. Step 3, link it into the list where we want it. Now, this is the head, so no traversing here. Lucky for us. No traversing. We have the head. We can just get there. And then we'll point it here. And then, yes, if you want to be a good programmer, new node equals null pointer. If you want to be a good programmer, go ahead and throw that in there. That's fine. So, Pig, that is not correct. Nope. We do not want to delete it yet. We do not want to delete it yet. We want it to be here. Okay? When we call new, we get this node out here. We have this now. This is our new memory. This is how we store things into the list. Recall that linked lists are not contiguous, right? They're not contiguous, meaning every node kind of has its own spot in memory all over the place. So when we call new node, our goal is to put it into the list. So Synthos asked, why would it be new node next? Well, if I said new node equals head, then I'm going to lose this. If I said new node equals head, this gets kicked out. And now new node and the head both equal the same thing. You have to remember that there's a pointer in here. There's a little baby pointer. Where is it? It lives in here. There's a little NXT in there. And what we care about is that we want that next node to look here. We want it to look, we need to link it into the list. We need it to look here. I need you to look at what the head was. So it's kind of, that's why we say that. We say new node next is equal to the head. If we said new node equals head, then that's a memory leak, I assure you. Now, Pig, I'm going to also remind you that this is just an insert. So we're going to call new here. Later in the program, the destructor will be called, in which the delete will then be called on that list. Okay? So Pig, does that make sense? This is just an insert. So there's no deleting that will happen here. Not one. But the destructor will later take care of that for us. The destructor will go through the list one by one. And I would recommend watching the last class, because I do believe I made a little Microsoft Paint diagram there, in which it will go here to here to here to here. It'll say delete this, delete that, delete that, delete that, delete that, delete that. Now we're done. Pig asks, you don't have to move the head to the new node? Yeah, you do. Here it is. Step 4, point the head to the new memory. You are correct about that. Step 1, we allocated it. Step 2, we put the item in the node. Step 3, we link it. This is the linking part. Linking always has to do with the next node. All right? Next nodes. Linking, if you're linking something, you're dealing with some next node here, some next pointer. And then, step 4, we're going to update the head, because now the head is looking at a new node to say this is the beginning of our list. And this avoids an alias, if you want, like a good programmer. Chef says the destructor uses the recursive clear list. Yes, it does. This is the recursive one. If it doesn't work, then we can just swap it to this one. Both of them should work, right? Either one would work. I'll just leave it commented out for now, but right now it's using the recursion. So are you okay with that? I do want to test this to make sure it works. So before we do that, we need to get one more thing out of the way. Actually, two. We're going to need to do this one and the operator. So let's get those out of the way. So we'll put this there, and we'll put this there. And this one's super easy. We're just going to return the size, right? And what the red arrow is that says new node. Is that its own pointer? Yeah, it is. Notice here, it's this one. So up until this point, we have access to two pointers. We have the new node pointer. We also have the head pointer. And up until that point, what does it look like? It looks like, it kind of looks like this. It looks like that. Maybe we died a little bit. You guys are all on edge. You're like, whoa, will it stop? So Pink, I hope that answers that question. There are two pointers, yeah. We have two pointers. We have the new node, and we have the head. And so we allocate it. Next thing goes in here. Next thing, we update it. We say, hey, that points to null, and then this points to whatever the new node was. If you'd like, you can come visit office hours or message me, as always. So that's our size. Let's go ahead and do this. Now, I would pay attention here. Here's where things are going to get fun. We want to print this list. We want to print this list. So what do we want to do first? If we're going to print the list, we're going to go through each element and print it. So what's the thing I always say that we need? If we're going to go through our list, what's the very first thing that we need? What's the very first thing that we need? I will wait. Oh, yeah, we will start a traversal node. That's what I'm looking for. Traversal node. So we're going to declare a pointer traversal node. It's going to have its own little arrow. Right? And what are we going to do? We're going to say, hey, whoops. We're going to say start at the head, print it, move to the next, 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 print it, move, and then we're at the end. So let's go ahead. We could do this recursively, but let's do it iteration. All right, we're going to do iteration here. So first thing, like you said, I would love a... How does one do that? So listen up here. Let's get started. First thing we need is the traversal node. Traversal node. Okay? That's the first thing. If we're going to move through the list, step one, we want a traversal node. Okay? It's kind of step one there. Now, where do we start? Well, Chef says we're going to start at the head, right? So step two, start at the head. So we're going to say that the traversal node is equal to the head. This is an alias. I agree with you. Yes, you're right. It should be a pointer. Absolutely, you're right. We did make an alias. Absolutely, you're right. But I told you sometimes that happens, okay? Especially in linked lists. And that's why Clang Tidy hates this assignment so much. Clang Tidy will not have anything to do with this assignment. It's like, you are just terrible. Okay, so, Cade, Chef, everybody else, are we up to date here? What our code has done? We have a linked list. The head is always looking at the head. We've declared a traversal node, and we've aliased it. We've aliased it. Notice this is a friend function, obviously. So, going to have to use the object to get in there. But we've made an alias, and now we've got two pointers pointing to the same node. So, what is our while condition here? What do you think? What is our while condition? How do we know when we're done? Now, counters, right? You could use size. In your assignment, use the counters all you want, but I would prefer we're going to do a different way here. How do we know we're at the end? How do we know we're not at the end of the list? Yeah, so you're doing counters, but Chef has learned, right? Null pointer. We're going to do null pointer. So we could do two things. We could say this. While the next node does not equal null pointer. What does that say? Well, that will make it stop when the traversal... Why do I keep doing that? What does that say? Well, that will make it stop here. That'll make it stop right here. Because it's going to check the traversal node next, which is this one. So the first thing it looks at is... let's see. The traversal node. And then you go up here and then into the next. What is it looking at? It's pointing at null pointer. So that works, but there's an issue here, and that is what if our list is empty? Now, what if this is null pointer? Guess what? You're going to get a seg fault here. Why? Because we're going to dereference this. So let's go ahead and just do it this way. What do you say? Synthos, I would like that. Yeah, while next is a null pointer, or while this one is a null pointer. Either one. Chef, you'll see when we get to push back, this one has a while condition that has to be while next. Similar with your swap. That's why those are a little more complicated, because this one you're going to have to check the T node next. That's why those are a little more complicated. In this one, we're not really inserting anything, so it doesn't really matter. Just trying to keep it as simple as possible. So if we know that this does not equal null pointer, let's go ahead and do an out. What do you say? And we're going to go into the traversal node next. Not the next, but the data. Okay. And I won't do an end line. Let's just do a silly comma here. Yes, absolutely. So Chef's way ahead of me. So how do we get to the next thing? Well, we'll say... the traversal node is equal to the traversal node next. Are you guys having fun yet? I hope you guys are. So this says, while not at the end, print our data, move to the next one. Having fun yet? I hope you are. So, what is that? How does that work? Well, let's just look. Let's just look here. It's pretty simple. We start at the head, right? We say while traversal node does not equal null pointer. Well, does traversal node equal null pointer? No. So we print SK there, and then we say traversal node equals traversal node next. Are we null pointer? Nope. Print it. Traversal node equals traversal node next. There we are. Print it. Print it. Print it. Print it. Boom. Now we're equal to null pointer. And guess what happens there? Well, that's when our while loop condition exits, right? Traversal node now equals null pointer. We're going to get out of that while loop and return. So are we happy with that? Let's take just a moment to answer some questions. I'm going to make some code to test this. So let's make an LL for ints. Link list. Okay. So this we'll call our default constructor. Okay, and then let's just add some elements. Push front. I don't know. I just want to make sure that everything is working as intended. We may need to take a few steps back. But let's go ahead and add some things here. Okay. And then I would like to maybe print it every time. All right, and then we'll check to see if our clear list takes care of it. So I'm going to do this just momentarily. I was not prepared today. Kate says push front pushes the What is that word? Index. No. So this is a list of integers. This is a list of integers. Just a list of integers. So that's what the linked list is storing. That's what it's storing. Does it make sense? It's not the index. If you want me to, I can make it like strings, right? That's kind of what we were doing with the example there. But no, we're just storing integers. Getting a call from Johnstown, Colorado. No, thank you. Where are we? We're in fall here. We're doing lessons, and we're working with this. I just saved it. We can put it here. We can CD to this here. We can zoom in. And then I guess I'll bring us back. I don't want to hide my mistakes from you guys. Moment of truth, shall we? G++ dash std equal C++11 ll2.cpp. I guess it has to be... Oh, it worked. It worked. Okay. Here we go. Here we go. Seg fault? Ha ha ha! No seg fault. It's working. Let's check Valgrind, shall we? Let's make sure that our clear list is working. All heap blocks were freed. And if we want to check one more thing, let's go ahead and make sure we have no invalid reads and stuff like that. Nope, it's all good. I'm a mastermind. What do you say? So look at that. What happens? We're putting something at the front every time. Do you see that? Obviously kind of hard to read there, so let's kind of condense it down. You see we start out with the 3, and then we put a 5 up front. Then we put a 4 up front, a 66 up front, a 947 up front. 5 head. Have you seen that? Okay, so let's do a few more. There's a few things we should do. Well, let's see here. Let's, insert is not really, that doesn't happen in your assignment, so let's not worry about that one quite yet. Let's go ahead and do probably push back. What should we do? Let's do push back, and then we'll try to see if we can do a sort real quick. All right? I kind of want to get that. In there for you, so you don't feel completely hopeless when it comes to the assignment. Now, I'm not saying that you will. I know I should be more positive, but I just want to make sure. Okay, so this is going to be push back, okay? What does that mean? Well, we're going to put our new element, let's say it's this one, we're going to put it at the end. We're going to put it at the end of the list. We're going to, like, pop it right there, okay? Now, we do have 15 minutes left, so here's how we're going to do this. I'm not really going to ask you any questions, okay? I'm just going to kind of throw some stuff at you. And if you have a question, please do stop me. But I'm not going to ask for input. Just see if you can keep up here. So I think you guys would agree the first thing that we have to do is we want to make a new node. Kate says, would you look for when next is equal to null pointer? Absolutely, Kate. That's 100% correct. That's what we're going to have to do. Very, very correct. Because we have to link it, right? We have to link it into the list. That's 100% right. So I think you guys agree that we have to make a new node here. Let's do that. I'm just going to copy it. What do you say? All right, step 1, allocate, put the data in there. Now, step 3, well, we can't link it yet. Well, let's link it, but we're going to need a few things, right? First thing we probably need is we have to go through the list, right? We're going to have to go, hey, while. Oh, now I'm at the end. Let's go ahead and throw this guy on the end of it, right? So, guess what we need? As always, a traversal node. I would love to just copy some stuff here, so I will. Ah, Chef, you guys are too good. Yeah, you guys are way too good. Yeah, this one's going to be on the end, right? This one's going to be on the end, so make sure it's on the end, right? You want to point that next node to null pointer. Very smart, very smart. Point to null pointer because it's on the end. All right. Step 4, we got to link it, right? So we'll need a traversal node. Always start from the head, right? And now we have to do a few things. So obviously we have to check this. We have to check to see if the traversal node next is equal to null pointer. That's going to be our check. Except the issue that I mentioned here previously, we can't do this check yet. Because, unfortunately, this would assume that head is not equal to null pointer. If you don't assume that, well, then you're going to get a seg fault. Or if you do assume that, you're going to get a seg fault, because this is going to be dereferencing a null pointer. So the first thing you probably want to check for is if the traversal node equals null pointer itself. Now, what happens there? What do you guys think? I'll ask you that. We want to link it. Let's say if this is null, what happens there? But this one is pretty straightforward down here. This is not empty, so we'll traverse it. I know I said I wouldn't ask you any questions, but here I am doing that. What a terrible person. I'm going to copy some code. Okay, so if the list is empty, that means that head actually contains nothing. So would you be okay with this? The new node? Yeah! That's right, Fuzzy, absolutely. If the list is empty, we're done. Let's just put it, let's just say, head, you get that thing. And if you want to, probably up here. I always gotta do this stuff. I suck at it. You agree with that? Yeah, you're just gonna put it in there. So that is, if the list is empty, head is now equal to our new node. And then we'll return, because we're gonna be done. Yeah. Thank you. Thank you for that. Saved me some time. All right, so yeah, if the list is empty, head equals new node, and we're done. But else, if the list is not empty, look at me naming things all differently here. Let's go ahead and just traverse the list. This says while traversal next does not, does not equal null pointer, we'll move to the next one. So what does that look like? Well, that's when you start here. We start at the head. We say, does traversal node next equal null pointer? No, it does not. Why? Because it's that one, right? So it does not equal null pointer. So what do we do? Traversal node equals traversal node next. There we are. Does the next node equal null pointer? Nope. 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 Yes, here we are, right? Does traversal node next equal null pointer? Absolutely it does. There it is. Found it, right? So at this point, we've reached the end, right? At this point, we've reached the end. And that traversal node will be looking at the very last node in the list. So what kind of code happens here? Well, this is when we link it in, where we say the traversal node next equals the new node. What does this line of code do? Well, what does that line of code do? Well, to start, I would just like to mention, thanks to Chef's keen eye, that we pointed that to null pointer already. And what we said was the traversal node next node, right? This is traversal node. And its next pointer is now looking at the new node. It's now looking at the new node. So we actually do have 3 pointers in play in this function. you'll notice that we have 3 pointers in play. We have a new node, a traversal node, and a head node. All these pointers are in play. And so we reach the end and we say, hey, there you go. You're on the end now. Make sense? Now we're done. Shall we test it out? What do you say? Traversal node next equals new node. If you want to say this, new node equals null pointer to be super safe. And then even if you want to, you're done at this point. So you could say traversal and equals null pointer too. Because you're done. You're officially done. Nothing more to do. You can get rid of them. Don't delete them. Just overwrite them. Let's go ahead and check it out, shall we? So we've got this. Let's go ahead and add something on the back. 25. Let's test it out. Did you follow that pretty well? I know I went kind of fast there, but I think you were able to get the gist. Of course, you can come back and watch this at 0.75 speed. 0.5 speed. Thanks to YouTube's amazing technology. That did not... obviously, I probably typed the wrong thing, didn't I? Whoops. My bad, my bad. There it is. See? Do you agree with that? You think we did it? You think we did it? I believe we did. So there it is on the end. Now if we want to val grind it just to double check to make sure we didn't do anything bad, it looks like we did not. All right. So you happy with that? Now, here's the sad truth. We are kind of at the end of class here. So for the swap function, I'm just going to give you some big hints, okay? I'm going to give you a bunch of big hints here. So everyone listen up, just pay attention, take notes. The good ending of code. Yeah, my code always works, but I've been doing it a lot. So let's just talk about a few things. Fun trick here, right? There's a trick for this one. So this one should not be hard at all in your assignment. Copy constructor should not be a problem. Where does the problem come in? It's this one. Why is this one rough? Well, it doesn't have to be rough. Because you have a few helper functions. Now, what does it mean, though, when we do an assignment operator? We're going to have to make a deep copy. We're going to have to make a deep copy. What does that mean? We're going to have two of these things, all with their own memory. Okay, so this, from the get-go, might be a little rough, okay? Because you're going to be, for every node, you have to allocate a new node. You've got to copy in the data. It could be a little rough. Now, I'm going to give you a hint here. If you look in your card, your deck function, you'll see this. Whoa, what is that? What is that? Well, I've included a little comment there of a function that we just coded. Right? There's a function there that we just coded. So if you want to uncomment that, and add a little definition, I don't know, maybe this one, then you can have a pushback in your card class. And then what happens next? Well, I don't know. For every card in the copy, push back to the this object. So maybe you can make that very, very easy for yourself, okay? Now, push front won't work. Push front won't work. Why? Because that will reverse the list. So if you do an assignment operator and you use push front, which is just add to top of deck, you're going to push everything in backwards, and then you won't get the right output. So you can't do that, all right? You cannot use For this here, you cannot use add to top of deck, right? You can't do that. But if you want to add this in here, you might be able to save yourself some help. Chef, you're right. Absolutely. You still need to traverse through the other list. You're absolutely right. You're absolutely right. Or, here, let's do a quick one. Let's do a quick one. And then I'm going to ask you guys to maybe hang out with me for an extra 2-3 minutes. I hope you don't mind, but I just want to give you the hints. Because I want us to complete this assignment. So let's just do this one real quick. This one's very easy. Well, I say that, right? So this is like your bracket operator, right? Doesn't like that. Okay. It's your bracket operator, so just return the element at the list. Return an element at the index. All right, so pretty much you're going to need a traversal node for this one. Right, traversal node here equals the head, and then for int j equals 0, j is less than I plus plus, not I plus plus, but j plus plus. Traversal node equals traversal node next. And then what? Return the traversal node data. See that? So what is that? Well, you're going to say, hey, I want to access my LL at, say, 0. So if the index is 0, then you're going to say this equals the head. J equals 0. J is less than 0. No traversing happens. And then, bam, you return the data there. If it's 1, and you say for j equals 0, j is less than 1, you traverse over once, and then you return the data there. Make sense? The one in the card assignment is a little different. But, Chef, when you say you need a traversal node, in some cases, you might be able to use this. And I'll just make a note. You may want to add something like this as well. I've gone over this in previous classes before. Notice here, this is returning a reference to the inside of the class. So anything that has a const is not going to allow you to call that. But if you want to make an extra helper function here, at, which does not return a reference to inside of the object, might help you out. Okay? So that's that. Now let's just talk about this swap cards thing. All right? We're going to be able to fit this in here. So just hang with me a little bit, all right? We're almost done. But I just want to make sure. I think I gave you the sort, all right? I think I gave you the sort already. Let's see. Oh, man, what did I do? Yeah, okay. So I gave you that sort already. If you open this, you'll see down here that I gave, well, maybe I didn't. No, I didn't. Whoops. But look, I gave you a hint here. All right, what am I doing here? Well, I'm calling the bracket operator, okay? So you can use that in other functions. That's what I'm indicating there. Notice here I do that as well. I call the bracket operator. Now let's talk about swap, all right? Unfortunately, I didn't do this, but I'll give you the hint. Here's the hint, folks. You're probably going to want to identify some things. For one, you're probably going to want a node, left node, and then find it. You probably want a node, right node, and find it. Now, what are those? Well, one of these will be A and B, right? One of these will be A, and the other one will be B. Or this one could be the B, and this one could be the A. All right, so you're going to want to find these. Find your left node, find your right node. And then you can do it at a different time or at the same time, but you also have to find the left previous node. All right, you have to find the left previous. What does that mean? Well, you're going to say, hey, if, left previous next equals left node, right? That's how you know, right? Because the left previous is previous to the left node. So you're going to have to find that one as well. Now, once you find them, you can do some swaps. But guess what? You're going to have to check some things. Is the left node equal to the head node? If so, probably going to have to update some stuff there, right? Going to have to update the head node. Yeah, that's pretty much it. All right. So I'll leave you with that. All right, and give it a shot. And let me know how it goes. All right. What you're going to need is some traversal nodes, and you're going to want these things. You're going to want your left node. You're going to want your right node, and you're going to want your left previous node. Fair? Are you guys all okay with that? Are you a little more comfortable with the assignment? And do you think that you'll be able to knock it out? I think with the information I've given you, it won't be terrible. Okay? I think you can do it. Yeah, exactly. Chef, very good question. If the head is the left node, very good question. If the head is the left node, then there is no left previous. Maybe left previous equals null pointer. Okay? Yeah, so I did give you a lot of hints, right? So I think you should be you'll have fun with the assignment still, all right? It still won't be super easy, but you're going to be able to do it, I assure you. Okay? So give it a shot. Message me. I hope you guys have a wonderful Thanksgiving, okay? Yeah, you can bug me in the DMs. I'll be available. I'm going to go home and see my mom, my dad, and my sister. But like I said, you can still message me. I hope you guys have a wonderful Thanksgiving, or at least have a wonderful break if you're not participating in that. Have a wonderful weekend. I'll see you guys next week. We only have 2 more classes left. So if you like seeing my face, make sure you come back next class, okay? I know next week is study week, but we still have stuff to go over, so I'm sorry about that. But please come back next week, okay? Yang, happy Thanksgiving to you. Cade, you as well. Pig, happy Codesgiving. That's pretty funny. Giovanni, you have a wonderful Thanksgiving. Santos, have a great one. Fuzzy, I'm glad it was helpful. I will hydrate. To you as well. Uchu, you as well. Thanks for coming. Chef, you as well. Thank you for coming. Kane, to you as well. Thanks for coming. Top Wolf, I'll see you during office hours. Thanks for coming. Brandon, you are welcome. And CS202 student, you are welcome. Have a good one. I'll see you guys next time. And to you, Hannah, as well. Happy Thanksgiving.